We will continue looking at decision trees. So like I said, there is a little bit more about trees that I wanted to look at, and then we will actually do an example today, okay, of how to construct trees. So starting from data set, how will you actually construct a decision tree, right? Okay. So we already looked at a couple of issues with regard to decision trees. What are the things we looked at? A. Well, how will you? No, we didn't talk about that yet. So when we looked at how will you pick a splitting attribute, right? Right. What is the splitting value in the splitting attribute? So how large you should go a tree, right? And how do you prune it? Okay, these are the issues that we looked at, right? But there are several other questions that we could ask, right? So when we talk about splitting attributes and split points, inherently we are assuming that our attributes are continuous, right? So that we can talk about a split point, right? So what happens if I have categorical attributes? So what are categorical attributes? Things that take some discrete values, right? So it could be things like color, right? Red, blue and green, right? Or it could be things what you normally would believe are continuous variables like age, right? But for a variety of reasons they have been recorded as discrete values. Young, middle aged, old, right? So most surveys and things like that, if you look at it, when you answer these things, they don't ask you for your exact age. They ask you, are you lesser than 25, are you between 25 and 34, or greater than 35, or things like that, right? So somehow it's discretized either by for reasons of anonymization or for convenience or whatever, you end up discretizing the values, right? So you quite a lot of circumstances, in fact, especially if you are involved with medical domain, right, or with this kind of marketing kind of a domain, right, you will end up having discrete attributes, right. So in which case, what is the meaning of a split point?
Like it would mean whether you have this property or not. Like
yeah, if it is binary, yes, right.
If you have some n things like
suppose it's color, right. So if we think about it, if I have Q right, so that is a key part here. Think of Q unordered values, right, age itself has some kind of ordering in it, so I can still fake it, I might have only 3 different age entries, but I can think of it as okay, young or middle aged and old, right, or young and middle aged or old, right. It does usually doesn't make sense to look at young and old and middle aged, because it's, I mean, I can say you can fake it, you can think of it as a ordered attribute, and then you can do that. But suppose it's unordered, right. So essentially what you would really have to do is think of splitting the values into 2 subsets, right. So like I said, let us say take color as an example, right. I might have to put okay red, blue and yellow into one group, and green and I don't know, give me a few more color names. That's about how much I know. Magenta, purple, okay. So all of this into another group, right? And so like that, right? I have to figure out some way of splitting it into 2. Okay. So how many possible splits are there like that? I have Q values. Huh? 2 power? Okay, good. Yeah. Right. So that many possible combinations. That's really not going to be feasible for me to go over all of them in order to pick the split point. Right. So that's exactly what we were doing. Right. If you remember our algorithm from the last class, we are actually going over all possible split points, and we said there are only finitely many such possible split points because we only have to look at n of them, right. But now you have to look at, even though I have only n values, I mean n data points for training, right, I potentially have to look at 2 power q minus 1 split points, right. So that is not going to be feasible. So there are 2 ways of handling this, actually there are 3 ways of handling this. The first one is if you have a you have a 0-1 outcome, basically this is what people would call a binary classification problem. If you have a binary classification problem, you can do one clever trick. What is it that you can do? Any ideas?
We can have Q attribute, like whether it's in Q, whether this attribute exists or not.
No, we do not want to explode the number of attributes, right. I am making it something very restricted here, right. I am looking at binary classification problems. So is that something that you can think of that you can do here? So what exactly are you looking at when you are trying to find a split point? What you are trying to do is trying to make sure that your prediction, right, when I do it on one half versus the other half is more accurate than the prediction I did on the data as a whole before the split, correct. So that is exactly what you are looking at from a split point. You are trying to find a split point such that it is more accurate than the other, right. So what you can do essentially here is you can pick one of the classes. Let us say you pick class 1, right. Let us say I have 5 predictors, or I am sorry, not, yeah, I have 5 predictors. So predictors are this unordered values, right. So let us say I have 5 values for a particular thing, let us say colors, right, red, blue, green, yellow, magenta, right. So let us say I have 5 colors. Now what I will do is I will take red, okay, I look at all the data points that have color red, okay, I will see what fraction of them are class 1, right. Then I will take all data points that have color blue, I will see what fraction of them are class 1, likewise for the other 3 colors, okay. Does it make sense so far? I look at each color, figure out what fraction of that color, that I mean data points having that color are of class 1. Now I will arrange them in some order, ascending order, let us say, of this probability, right. When I say fraction, it means what fraction, that is a probability that a data point having color red will be class 1, right. So from the training data, right. So I will arrange it in ascending order of this probability, then I will just treat it like any other ordered variable and then I will split, right. Does that make sense? So why does this help us? Think about it a little bit, right. Suppose I have put it in some order, right. Let us say that right. So red has 0.2% of the data having class 1, right. Right. Let us say suppose something like this. No, they need not be. Why should they be? I am just looking at each fraction of the data points with color red that were class 1.
Those colors in this class.
No.
Each data point can have more than one.
Other classes
More than one?
Other classes.
Color. No. There is one attribute that says color of the data point, okay, whatever is it, the one attribute that says color of the data point, right, and that attribute can take 5 values, red, blue, green, yellow or magenta, right. Suppose it is taken color red, I look at what fraction of those data points that have color red are of class 1, right. Suppose I find that there are 10 data points that have color red and 2 of them are of class 1, then it is 0.2. Okay. So obviously, so these numbers do not have to sum to 1, right, because they are only for that, right. Now you can tell me what is a good place to split this. Okay, before somebody asks me a question about what if it is exactly 0.5, okay, there you go.
Either the Y or the M.
That's 0.2, 0.3, 0.4, 0.45 and 0.55. Ah.
You would rather
Split
choose
on the R so that we
some
can-
property where you have
Less
a lot of
number
one thing. So in which case R would be preferable.
See how we go about doing the lot of one thing.
Most of the
Ah, good point. Yeah. So yeah, so you know how to do this. Come on, pick a thing and tell me what. You know the Gini index, eh? You know the Gini index or information gain or something like that, right? So all of you know that, or misclassification error. Let's use misclassification error as the splitting criterion. So for me to find an optimal split, I don't really have to consider R and Y going to one part, right? B, G and M going to the other side, right? So it will either be here, or here, or here, or here, or here. I mean that's it's a really bad attribute to pick if it is here, right? But it will only be left to right, right? So these are the only subsets I need to consider. I don't have to consider all of the other subsets, right? Does it make sense? It's kind of, you can intuitively see this here, right? So since this fraction of the class 1 keeps going up, right? So either you break here or here or here or here. So that's a heuristic for this, right? In fact, with a little bit of thing, you can show that for two classes, right, you will get the same optimal split, right, by using this method as you would get by exhaustively searching through all the splits. Okay, is that clear? I am seeing too many puzzled looks. We did decision trees day before yesterday. People remember decision trees? Okay, so in split points, if I have categorical attributes, split points are going to be like subsets, right? Subsets of the values the attribute can take, right? So split points would be, okay, do I consider red and green to one side, blue, yellow, magenta to the other side? Yeah, that's good, potentially a combination, right? So in this case I am saying you do not have to worry about all possible subsets. All you need to do is, after you have done an arrangement like this, okay, wherever you choose to split depending on the criterion you are using, so wherever you choose to split, right, so everything to one side will form one subset, everything to the other side will form another subset, and these are the only subsets that you need to consider while you are trying to find the optimal split. You do not have to consider all the 2 power q minus 1 subsets, okay.